Hello and welcome to Home Science Lessons with Mr. Mac. Lesson 6, Particle Model and Pressure in Gases. So hello again everybody. Remember to turn your phones off or put them away please, or shut down any other windows on your computer which might be distracting. That would be fantastic. Right, lesson design as normal. Some retrieval practice, some teacher instruction from me under the camera, all about gas, pressure and particle model, a chance to drill, and then obviously a chance to practice and apply what you've learned today. So our retrieval, just before we do that, I've put up the Slop task from last time. So that was the first page. If you haven't had a go at this already, please have a go. If you have had a go, you can check your answers because they're going to appear now. So energy equals mass times specific latent heat. And there's your answers there. And Slop 5 part 2, I'm going to go through the answers to that and the working out under the camera shortly. Okay. Right, retrieval practice then. I've got some retrieval practice on quantitative chemistry. So get ready to pause the video and have a go. Whenever you've got your pen, pencil, paper, whatever else you need, pause and have a go now, please. And there are the answers to that one. Next retrieval slide is all about diseases and pathogens, how they're spread. So where there's a question mark, that's what you need to write down the answer for. So rather than write out the whole table if you don't want to, you can just number the question marks, 1, 2 on the top line, 3, 4, 5, 6, 7, 8, going from top left to bottom right. So pause, have a go now, please. And there are the answers. Third and final retrieval slide today is on heat energy transfer, conduction, convection, and what happens to particles during the process. So pause and have a go, please. And here are the answers. Well done. Anything over the 3 slides that you didn't get, please make a note, pause the screen, make a note, and do some more drilling and revision of those topics. Thank you very much, as always, for working hard and filling in any gaps in your knowledge. So I'm going to go over to the camera in just a sec because we are going to go through the working out from Slop 5 part 2 from last time. So last time we were calculating specific latent heat. This was the second half of our Slop questions. So calculate the energy needed to melt 0.49 kilograms of aluminium. Specific latent heat of fusion is 399,000 joules per kilogram. So that one's very straightforward. You just multiply the two numbers and we get an answer of 195510 joules. Second question is specific latent heat of fusion of element Y if 405 joules of energy are used to melt 0.6 kilograms. So for that one, we need to do a bit of rearranging. We got the equation, energy equals mass times specific latent heat. We know the energy in joules, we know the mass, but we don't know the specific latent heat. So we need to divide both sides by 0.6, and that gives us an answer of 675,000 joules per kilogram. Then the last one, what mass of lead can be melted using 58,000 joules of energy? The specific latent heat of fusion of lead is 25,000 joules per kilo. So we know the energy is 58,000. We know the specific latent heat is 25,000. So again, we need to rearrange the equation to get M on its own. So divide both sides by 25,000, and it gives us an answer of 2.32 kilograms of lead. So that brings us on to our new knowledge, which is on particle theory and gases. So point number one, what is or what causes gas pressure? So gas pressure is the force exerted, so that means the force exerted by particles in a gas in a given area. So gas pressure is the force exerted by particles in a gas in a given area. Another way to look at it is the force of the gas particles colliding with the walls of the container. So if you need to, pause the video and have a go at writing down your notes, please. Okay, next new piece of knowledge. Explain how temperature affects pressure in a gas when the temperature goes up or when the temperature goes down. So these are a few bullet points to help you with that. So when the temperature goes up, kinetic energy of particles increases. That means that their movement energy is more. Internal energy of particles increases. Particles hit the surface more. That means like the surface of the container, whatever it's kept in, and pressure increases. So particles have more energy, they're whizzing about more, they collide more with the walls of the container, and that causes pressure to increase. So that's when you heat up a gas. So what about when we decrease the temperature? What effect does that have? Well, the opposite, really. Kinetic energy in particles decreases. Internal energy decreases. Less particles hit the surface. And pressure decreases. So if you need to at this moment in time, pause the video and jot down any particular notes that you need from that. So what about a particular worked example, right? You've probably been going out riding your bike a lot at the moment during this current situation. So what happens to tires on a sunny day? Explain how tire pressure will change over the course of the day. So what about when it's a hot day? So if a gas is heated up, its particles move around more quickly. they hit the walls of the container harder and more often. This increases the pressure. There's more collisions between the gas particles and the side of the container. Another thing you could do to increase pressure is add more gas particles, by pumping up your tire. The more gas particles there are, the more collisions there are as well. So sometimes the pressure gets so great that the container bursts. This is why balloons and tires burst if you blow them up too much. This is also why deodorant cans carry warning signs not to leave them in the sunshine. Because if they get too hot, they'll explode, potentially being very, very dangerous. So to summarize, if a gas is heated up, its particles move around more quickly, they hit the walls of the container harder and more often, and this increases pressure. Sometimes the pressure gets so great that the container bursts. This is why balloons and tires burst if you blow them up too much. This is also why deodorant cans carry warning signs not to leave them in the sunshine, because the particles will get hot, they'll start to move around more collisions with the inside of the container, and if the collisions are harder than the force of the container acting inwards, it will explode. So never ever try and pump up your bike tires at the or pump up an inflatable at the tire pump at a garage, because you could blow the thing up. You could blow it to smithereens. So when you've written your notes, you pause now if you like to write your notes. And we'll just go back to the PowerPoint, because you know now what you need to do. Embed the knowledge. Remember, drill, drill, drill. Drill is thrill. So how are you going to embed that knowledge? You might want to get your notes after reading them, cover them up, and then write down what you can remember from memory. So look, cover, write, check. Or you may want to get someone, if you're lucky enough at home, have someone at home to test you on the knowledge, obviously after reading it first. So now we've had a go at our new knowledge and our retrieval, and we've had a go at drilling and embedding the knowledge. So it's now over to you to apply the knowledge and practice using it. So Slop 6 is on the next slide, but it'll also be attached to show my homework as well. So here's Slop 6. There's a couple of pages, so pause and have a go now, please. Here's the next part of Slop 6. Again, whenever you're ready, pause and have a go now, please. All right, the answers to Slop 6 will be revealed next time out when we study specific heat capacity and calculations, which sadly will be the last lesson in our particles topic. So that just remains for me to tell you a few things before we go. Remember to do some retrieval practice if you were a bit rusty on some of those facts. Please complete Slop 6 and try your hardest. You can check your answers next time. And please tell any of your friends if they're not yet really tuned in to watching the videos and writing notes from them. So just remains for me to say thank you for working hard at your retrieval. Thank you for working so hard on the online lessons and the Slop tasks. And thank you in advance. Look out for your recall test later in the week. Thank you in advance for that. So see you soon and goodbye. Goodbye.